In this example, we'll once again be looking at the arc length of a function. Notice this function here is x equals, meaning that it's going to be in terms of g of y that this function is. And that means we're going to be using the secondary formula, this one here, where the arc length is equal to the integral from c to d of 1 plus the derivative of the function in respect to y squared dy. So what I'm going to do is I'm going to go through taking the derivative of this function very carefully. Notice my bounds are from c to d, 1 to 4. So I can set up my integral over here being the integral L equals the integral from 1 to 4 of the square root, and I'm going to leave this interior stuff empty, dy. I'm going to go ahead and find out what 1 plus the derivative function squared is. So here I'm going to take the derivative of g of y. The derivative of any constant times anything, I'm going to carry that constant through. The derivative of y minus 1 to the power of 3 halves, that 3 halves comes down, and I have y minus 1 to the power of, and I subtract 1 from that power, 1 half. Don't forget, just to check, what is the derivative of the interior of that function in respect to y? Well, the derivative of y minus 1 is 1 minus 0, so that's times 1. Again, we don't need to write that 1, but that 1 is in there just to make sure that we see it. So this provides me with, when I simplify it, 2's cancel out, the 3's cancel out, and I have y minus 1 to the power of 1 half. At this point, I'm going to have to add 1 to this function. So, I'm sorry, I'm going to have to square this function. G prime y squared is y minus 1 to the 1 half to the power of 2, which gives me y minus 1. And then I'll do 1 plus g prime of y squared, and that's going to give me y minus 1 plus 1, giving me just y. Now you'll notice here I've taken this formula, 1 plus g prime y squared, and I've done g to g prime, I've squared g prime, and then I've added 1 to it. So whatever's here goes back inside to the radical, and that's all we have inside that radical. So conveniently in this particular case, I have the integral from 1 to 4 of y to the 1 half dy, which we should be able to integrate relatively smoothly, increasing the power to the 3 halves, dividing by that power 3 halves, or multiplying by 2/3, evaluated from 1 to 4. In this case, what we're going to find when plugging in these values is 2, 4 to the power of 3 halves, divided by 3, minus 2 times 1 to the power of 3 halves, divided by 3. In this case, this provides me with 4 to the power of 3 halves is going to be 2, because the 1 half power is a square root, so the power of 3 is 8. So I'm going to have 2 times 8 divided by 3, minus, and 1 to the power of 3 halves is simply going to be 1, so this will be 2/3. This will provide me with 16 over 3 minus 2 over 3, in the result giving me 14 over 3 as the arc length of this function here in respect to y from 1 to 4.